So in this question, we're asked to show that cos 3a is equivalent to 4 cos cubed a minus 3 cos a. So we start off and we'll work from our cos 3a and try and get to this right-hand side. So to begin with, we'll take a look at the compound angle formula. So this tells us that cos of x plus y is going to be equal to cos x multiplied by cos y minus sin x multiplied by sin of y. At this point, we don't yet have our equation in the form where we can do this. But what we can do is we can split our 3a up into a 2a and a 1a. So therefore, writing this down, we have cos of, and then we'll put brackets in this time, we'll have 2a, then we're going to add on a. So now what we can do, we can use the compound angle formula with x equals to 2a and y equal to a. So we can therefore write this in, and we can say that cos 3 of a is going to be equal to, so we'll have cos of 2a multiplied by cos of a, and then we're going to subtract sine of 2a multiplied by sine of a, where we've just replaced x and y in this equation here to give us our equation in terms of a, which is what we're working with in this question. So now what we can do is we can use the double angle formula. So we notice we have a cos 2 of a here and a sine 2 of a here. And we can see here we have equations, the double angle formula, which gives us expressions for these here. So we'll substitute these in. So we'll just carry down our equals here. And then we have that cos 3 of a is going to be equal to 2 cos squared of a minus 1. Then we multiply all of that by cos of a, and then we're going to subtract 2 sine a cos of a, and we multiply that by our sine a here, sine a. So there we go. So now we're ready to move on to the next stage, and what we're going to do for this next stage is expand out our brackets. So this first bracket will expand it out and multiply that term and multiply that term too. So we'll have 2, and then we have a cos squared a multiplied by cos a. So that's cos cubed of a. And then we're going to subtract 1 minus cos of a, which is cos of a. And then looking at this second bracket here, we're going to have negative. That's our 1 term, so we just multiply it, and it's going to be 2 sine squared a multiplied by cos of a. So for the next stage, we note that in the question, the right-hand side, which we're aiming for, everything is in terms of cos. But we see in our equation here, we still have this 2 sine squared a. So we know we also have the trig identity, sine squared x plus cos squared x is equal to 1. So we can rearrange this for sine squared x, and we can substitute this in for sine squared x here. So bearing in mind we have 2 sine squared a, so we'll just therefore do this in the purple over to the side here, and we have that 2 sine squared x is going to be equal to, we multiply everything by 2, so 2 minus 2 cos squared of x. So we can then substitute this in to our equation over here. So this is going to leave us with 2 cos cubed of a minus cos of a. So then we'll now substitute in our new part over here. So we'll put our brackets in first, and we'll have 2 minus 2 cos squared a, and then multiply that by cos of a. So then all that's left for us to do now is expand these brackets further. So our first bit remains the same, 2 cos cubed a minus cos of a. Then this time we're going to have minus 2 lots of cos of a, and then we have take away the negative, so we'll add on 2 lots of cos, so we have squared a multiplied by a, so that's cos cubed of a. So then now we can combine these terms together. So we now have 2 cos cubed a, and we have 2 cos cubed a, and then we have cos of a and cos of a here. So we can combine all of these like terms together, which is going to leave us with the fact that cos 3 of a is equivalent to, so we add our cube terms together, so that's going to be 2 plus 2, which is 4 cos cubed a, and then we have negative 2 minus 1 lots of cos of A, so that's going to be negative 3 cos of A. So when we look back at the question, and this is exactly what we were asked for, we were asked to show that cos 3 of A was equal to 4 cos cubed A minus 3 cos of A. So we've therefore completed this question. We see that this question was worth 4 marks, and we receive our first mark for knowing to use the double angle formula and getting to this stage here, where we had that cos 3 of A was equal to cos 2A multiplied by cos A minus sine 2A multiplied by sine A. We then receive our second mark for knowing to use the double angle formula and substituting this in. So this was at this point here, we got that. So we used the double angle formula here and here. And then thirdly, we receive our third mark for knowing to use the third trig identity. So this was this part here. So we receive our third mark here, and then we receive our fourth and final mark for concluding with the correct answer, which was cos 3 of A is equivalent to 4 cos cubed A minus 3 cos of A. So in this question, we're asked to solve for x between negative 90 degrees and 180 degrees, the equation 1 minus cos 3 of x equal to sine squared x. So we have our equation here, and we know that if we want to solve something like this, we must have everything in the same form. So that's either all the cos's or all the sines. So for our case, we're going to convert everything into cos. So we know we have the trig identity sine squared x plus cos squared x is equal to 1. So what we can do is we can rearrange this for sine squared x, which will give us that sine squared x is equal to 1 minus cos squared x. So what we can do is write this in here. So we'll therefore have that 1 minus cos 3 of x is equal to, so we'll have, like I said, we'll rearrange this equation here. So that's going to give us 1 negative cos squared x. So we also have that this cos 3 of x term, well, we can use what we did in part A. So we have that cos 3 of A is going to be equal to 4 cos cubed A minus 3 cos of A. So this is exactly the same in this question, apart from we'll have x's instead of a's. So being careful with where we have our brackets because of this negative here, we're going to have 1 and then we subtract. We'll put our brackets in there. We'll have 4 cos cubed of x, and then we're going to subtract 3 cos of x. And we have still that is going to be equal to 1 minus cos squared x. So what we can do is we can then expand these brackets by multiplying by the negative and then taking this side here over to this side and equating this to 0. So this will remain as 1, then we have minus 4 cos cubed of x, and then we're going to add on to that because the negative 1 multiplied by negative 3 cos x is going to be positive 3 cos x, and then we then subtract 1 and add cos squared x, which is equal to 0. And therefore, what we can do, continue over here, we can tidy this up a little bit. We can see our 1's here. We have a positive 1 and a negative 1. They'll cancel out. So that's going to leave us with cos squared x. And we're going to add on 3 cos x. And then our final term is going to be negative 4 cos cubed of x. And we recall that this is all still equal to 0. So we can now take out a common factor of cos x. So bearing in mind we're wanting to solve for x, so the easiest way to do this is firstly take out cos of x, and that is going to be then multiplied by cos x plus 3, and then we're going to subtract 4 cos squared x, and that's all still equal to 0. And then now what we can do is we can say let cos x equal y, and we have the following quadratic inside the brackets here. We will have negative 4y plus 3, and then taking the negative out, we'll have negative lots of 4y minus 3. And then what we see is that this will factorize into, so we keep the negative outside and we have 4y plus 3, and then we're going to multiply that by y minus 1. So what we can do is we can relate back to what we have here, and we can, firstly, we'll take out the negative and put the negative in front of here, but it doesn't really matter because we can multiply both sides by -1 anyway, so that will cancel out the negative because -0 is still 0. So then we'll therefore have as follows, we'll have cos of x, and then multiply that by 4 lots of y plus 3, and remember that y was equal to cos of x, so 4 cos x plus 3, and then in our other bracket we'll have cos of x minus 1, and that's all still equal to 0. So then what we can do now is we can start to solve the equation. So we'll have our first term here, cos of x, that's going to be equal to 0. And then secondly, we'll have that 4 cos of x plus 3 is equal to 0. And finally, we'll have that cos x minus 1 is equal to 0. So solving these with the calculator, we put in here, we have that x is going to be equal to cos -1 of 0, which comes back as 90 degrees. We have here that what we can do is we'll say that cos of x is equal to -3 over 4. So how do we get that? We subtract 3 from both sides and then divide by 4 to get this cos x on its own. And then putting this into the calculator, we get that x is equal to 138.59 and so on, which will round to 139 degrees. And then finally, we have here that cos x is going to be equal to 1, and we get that by adding 1 to both sides. So putting that into our calculator, we have that x is going to be equal to 0. So in questions like this, we want to show all the solutions, and we need to look at our range to see how we do this. So we know that we're looking for x is between -90 and 180, and we know in a case like this, we'll have a cast diagram. And for us here, what we're going to have is we tick the all box since we have positives, and then we're going to tick the cos box as well. So first off, taking a look at x equals 90, we know that if we come back from 0 like this, we're going to have -90, which is in a range. So we have also that x is equal to -90. We see if we do the same with our other two options. Firstly, with x equals 0, 0 take away 0 is going to be 0, so that's a standalone solution. And then we see that if we subtract 139 from 0, it'll be out with our range. So therefore, we can write a concluding statement that solutions are going to be x is equal to -90 degrees, and then we'll have the next solution is 0 degrees, 90 degrees, and finally 139 degrees. And therefore we've completed this question. We recall looking back that it was worth 4 marks, and we'll now go through where we picked up those marks. So we pick up our first mark for getting it into the form where we had cos squared x plus 3 cos x minus 4 cos cubed x was equal to 0. So we picked up that mark at this stage here. We then picked up our second mark for then going through this process here where we separated our brackets, and we pick the mark up for this line of work here where we set our different terms equal to 0. So we'll put our second mark in here. We then receive our third mark for having 2 of the 4 solutions. So we'll just pop that one in here. And then we receive our fourth and final mark for having all 4 solutions correctly. So we'll put our fourth mark in there. And that's us completed this question.